Hi. Um, yeah, so earlier on Tuesday, Dr. Shushadu gave presentation about AZP-Big, our software for preprocessing raw and targeted mass spectrometry data. And today in my talk, I'll go over a few details about AZP-Big design and implementation. Okay, so first of all, AZP-Big is a part of our workflow that includes AZP-Big itself for data preprocessing and cloud application AZP-KDB for library matching. And first of all, when we just start developing AZP-Big, we want to make sure that we can process thousands of samples and large cohort studies on a typical desktop computer. And we made AZP-Big design modular and flexible so that it can be run on a single computer or on a cluster of computers. It can be run through graphical user interface or in a terminal. And on the bottom right, you see a workflow for processing LC MSMS data, and we work with Dr. Susan Sumner's group to design this workflow. As I said, the modular design is really key in AZP-Big, and what it means is that we store all processed and intermediate data on a disk, and each processing step, for example, chromatogram building reads data from disk, process the data, and then writes data back to the disk. And then next step, peak detection, reads data from disk and writes results to the disk. So what it does, it lets us execute each processing step on each sample in parallel whenever it's possible. It helps release system resources after executing each processing step. And it avoids storing the entire data, study data in memory. So the memory consumption we found was really issue because if you process multi-batch studies, you have thousands of samples and hundreds of gigabytes of data. You cannot keep all this data in memory. So memory consumption was really the issue that we wanted to deal with. And on these slides, you can see a couple of figures. The first figure shows memory consumption for dataset 1, which is small dataset with 74 samples. And you can see that each this figure is split into each processing step, and you can see that each step process data and then release the memory. And then for EIC, built-in peak detection, alignment, and so on. And the entire process takes about 25 minutes. Figure on the right, you see results memory consumption for much bigger data set. It has 36 batches, 104 samples in each batch. In total, it's 3,700 samples. But of course, it takes more time to process this data set, but the memory consumption stays basically the same. So that's about memory optimization. And if we want to speed up our processing of multi-batch data, is we can install AZP-Big on a cluster of computers. As I mentioned earlier, you can run AZP-Big through graphical user interface, or you can install and run AZP-Big through terminal. So here you can see some examples of commands on the left. And basically, after installing it on a cluster, we can really parallelize the whole process and process multi-batch studies much faster. In addition to that, we worked on individual algorithms and on optimizing and improving individual algorithms that include in-batch and between-batch alignment, peak grouping, MS pairing and other algorithms, but I'll skip details. Well, I think that's it for me. Thank you.